Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is a Probability and Statistics 2 for February-March 2021, and the code is 9709/62. So let's move on to question number 1. Okay, so for question number 1, a construction company notes the time T days that it takes to build each house of a certain design. The results of a random sample of 60 such houses are summarized as follows. So you are given summation T and summation T squared values. Now A, calculate a 98% confidence interval for the population mean time. Okay, so before we get this confidence interval, we need to get the mean and also standard deviation. So the mean of the T is basically summation T over N. That is 4820 over 60, because 60 houses, so the N is 60. Then you will be getting 241 over 3. Okay, now the standard deviation or the variance, sample variance, it will be 1 over n minus 1 multiplied with summation t square minus square of the summation t, then over n. That means now here it will be 1 over 59 multiplied with 392050 minus square of 4820, then over 60. Okay, and then this is going to be 14530 over 127. So I'll leave it in fraction. Now for 98% confidence interval, for population mean, which is mu, that is going to be T bar plus minus. Okay, now 98% means that the middle region is 0.98. Now when you look at here, okay, the population distribution is not given in the question, but then the n is large, 60. So according to the central limits theorem, as long as the n is large, which is greater than 30, we are going to use the normal approximation because it will be approximately normal distributed. Okay, therefore I'm using the normal graph. Now for the normal graph, we need to know the region towards the negative infinity. So since the middle value is 0.98, that means it will be another 0.02 shared by two parts, lower and upper part. Therefore, each part is 0.01. So with this 0.01, the total region towards the left side, it will be 0.99. Okay, so now when 0.99, then you have to read from the normal table. The critical value is going to be 2.326. Right? That is our critical value. Okay, or probably here I can just write z. Then after that, square root of st squared over n. So then my t bar is basically 241 over 3. Then plus minus, the z value is 2.326. Then square root of st squared. So it is over here, 14530 over 127, then divided by 60. Okay, because the n is 60 now. Then now here, you will be getting, using the minus to calculate the value, the lower limit, 77.6, correct to 3 significant figures, and for the upper limits, it will be 83.1. So that's the confidence interval for population mean, which is 98% confidence interval. Okay, now B, explain why it was necessary to use central limits theorem. Okay, so as I mentioned just now, you are not given the population distribution. Okay, so probably you can just write the population is unknown. The population's distribution. Okay, or probably you can write it is not normal because the question never mentioned, or the population is not normal. It's not normally distributed. Alright, so that's the reason for us to use the central limit theorem. And some of the n is large. Okay, now question number 2. The diagram shows a graph of probability density function f of a random variable x. So when you see this word, that means that it is continuous function. So the x is continuous random variable. Find the value of the k. So from here we know that the total probabilities is 1. Okay, and since this is probability density function, therefore integration of the limits from 0 to k, because the function is defined for 0 to k. Other than that, it will be 0 here. So the total properties, which is integration fx from 0 to k, it will be 1. So now this integration is same as area under the curve, equals to 1. Okay, so now area under the curve, this is basically a triangle. So triangle means the area is half times base. The base is k value, and then the height is half k. Okay, then from here I will get half k bracket half k equals to 1. That means 1 over 4k is 1, hence my k is 4. Okay, half k times half k is half k squared. So k squared is 4. Now your k is plus minus 2. But then when you look at the graph here, your k is greater than 0. Okay, so now here you write, since k is greater than 0, therefore your k is 2. So that's the solution for A. Now B, using this value of k, find fx for x between 0 and k, and hence find the ex. So this is the first part, and ex is the second part. So now here we know that the function is basically this straight line. This is your straight line. So to find the straight line, we need 2 points. Okay, then we can find the y equals to mx plus c. So then here I found 2 points. So basically when the k is 2, okay, from the previous part, your k is 2, that means this point is basically 2, right? The coordinates will be 2, 0, and then for the y-intercept here, half times 2 is 1. Basically this point with coordinates 0, 1. So now with these 2 points, I can find the straight line equation. So I will be using 0, 1, and 2, 0. Okay, so then here the gradient m equals to y1 minus y2, so 1 minus 0 over 0 minus 2. Then you will be getting negative half. Now I use a formula equation of fx, that is the straight line. That means fx, instead of y minus y1, our formula was y minus y1 equals to m bracket x minus x1. So now that my y changed to fx. So then y minus y1 equals to m bracket x minus x1, because your horizontal axis remains as x. Okay, it's just that the vertical axis has been changed to fx here. So means that now you will be getting, okay, I just pick 1 point. So probably I use 0, 1. So it will be fx minus 1, okay, m equals to negative half, then x minus, the x is 0. Alright, so then from here you will get fx equals to this, you bring in, I will be getting negative half x, and then the minus 1 on the left side will be moved to the other side. Therefore, you will be getting plus 1, because half times 0 is 0. So this is your fx, which means now here I will just write my function is basically negative half x plus 1 when the x is defined from 0 to k, because the straight line is defined from x goes to 0 until k. Okay, so just add on the limits. So done for the first part. Now the second part is to calculate the fx. So then the fx is basically, okay, I just do it here. So not fx, ex, sorry. The ex is defined as integrate x fx dx. And now your fx is defined from 0 to k. So now I have to change my k into 2. Okay, which means now my integration will be integrates from 0 to 2. Then now here, your fx is this straight line, negative half x plus 1. So just replace. So 0 to 2, x times negative half x plus 1 dx. And then this is going to be equals to integrate 0 to 2, negative half x squared plus x dx. So when you integrate, right, our formula is integrate x degree n dx. This is x degree n plus 1 over n plus 1 followed by plus c. So use this formula to integrate. And of course now we are solving definite integral, therefore there is no plus c. Okay, so from here I will write negative half, then x squared becomes x cubed over 3, close bracket. The x becomes x squared over 2. And then now here you will be getting, I will rewrite, this is going to be negative 1 over 6 x cubed plus half x squared. And replace the limits. Replace the x by 2 first. So when you replace the x by 2, I will be getting negative 1 over 6 2 cubed plus half times 2 squared. Then I minus when x equals to 0. So then from here, at last, you will be getting 2 over 3. So that is our ex, expected x. Okay, now see, find the p so that or such that probability of x is between p and 1 is 0.25. So whenever you find probability, is basically you integrate. So now here I will integrate because p to 1, okay, so from p to 1 fx dx equals to 0.25. Now for this fx, just copy the previous fx, that is negative half, right, x plus 1 dx equals to 0.25. Now this 0.25 you can just remain or you can change to 1 over 4. Okay, probably I change to 1 over 4 later on or now. Now for the integration, okay, again use back this formula. Therefore you will be getting negative half, the x change to x squared over 2. Then the plus 1 change to x, because for integration we always add 1 degree of x to the function. Then equals to 1 over 4. Then from now here, okay, so replace the x first. And at the same time, the negative half and this over 2 can be grouped together. That is negative 1 over 4. So I will write negative 1 over 4 x squared plus x. Then the limits from p to 1 equals to 1 over 4. Okay, now replace the x by 1. So I will get negative 1 over 4. 1 squared is still 1. Then plus 1 and minus when the x is replaced by p. So you will be getting negative 1 over 4 p squared. Then plus p, that equals to 1 over 4. Okay, now the question says find the value of p, means just 1p. Then from here, since all over 4, or probably I can just simplify first. Now look at this, negative 1 over 4 plus 1, that is 3 over 4. Okay, and then the minus will times into the bracket. So that means the next term is going to be plus 1 over 4 p squared, then minus p, after that equals to 1 over 4. The 1 over 4 moved to the other side, right? So negative 1 over 4. So that means now here I will be getting 3 over 4 minus 1 over 4, that is 2 over 4. Then plus 1 over 4 p squared, then minus p equals to 0. Now to eliminate the over 4 there, so I just times 4 to the whole equation. Then I will be getting 2 plus p squared minus p equals to 0. Now this is a quadratic equation, so we need to arrange them in the order first. so that I will be getting p squared minus p plus 2 equals to 0. Okay, wait, times 4, so the last term it should be minus 4p and not just p. This is minus 4p. Okay, so this is the quadratic equation that we have obtained. Now, we need to solve the p from this equation. You will realize that this quadratic equation cannot be factorized. Therefore, we need to apply the quadratic formula. Using this quadratic formula, x equals to minus b plus minus square root of b squared minus 4ac over 2a to solve this quadratic equation. So now my a is going to be 1 because 1p squared, my b is minus 4, and then my c is positive 2. So now since your equation in terms of p now instead of x, that means when you apply this quadratic formula, change the x into p. So the p equals to minus b plus minus square root of b squared minus 4, the a is 1, c is 2, then over 2 times 1. Okay, then from here you will be getting 4 plus minus square root 8 over 2. So then now the square root 8 is basically, look at here, square root 8 is square root 4 times 2. Then we have a formula, square root AB is square root A times square root B, so you can split. Therefore this is going to be square root 4 times square root 2. So square root 4 is going to be 2, then end up with 2 root 2. So now here I will be getting 4 plus minus 2 square root 2 over 2. And then now all the terms divided by 2 means that the first term is 2, then plus minus square root 2. Now when you look at the question here, okay, so then p between 0, you need to calculate x between p and 1. Okay, and we know that the x is actually greater than 0 and up to 2. Alright, so that means now I know that my p is basically from 0 to 1 because it's less than 1 here. Right, so now p is between 0 and 1. Therefore, your p is going to be 2 minus square root 2. It cannot be exiting 2. So therefore, we cannot choose a plus sign. So that is your value of p. Okay, question 3. An architect wishes to investigate whether the buildings in a certain city are higher on average than buildings in other cities. He takes a random sample of buildings from the city and finds that the mean height of the buildings in the sample. He calculates the value of the test statistic z and finds that z is 2.41. Okay, now A, explain briefly whether he should use a one-tailed test or two-tailed test. Now, he wishes to investigate whether the buildings are higher. Okay, so because of higher, that means it will be one-tailed test. Alright, because now you need to explain. So, one-tailed test, because he is investigating whether the buildings are higher. Okay, so when higher or less or more, it will be one-tailed test. So that's the explanation. Two-tailed test is used when it is not, right? It is not sure whether it's higher or lower. It's just that does not agree with the given statement. Now B, carry out a test at 1% significant level. So from here, he's checking the heights of the buildings, right? So therefore, here I will write H naught mu1 minus mu2 is equal to 0, means no difference. Okay, then H1 is mu1 minus mu2 is greater than 0. That means the mu1 is the height, the population mean height of the buildings in a certain city. Therefore, this is basically same as mu1 greater than mu2. Okay, so now we always write in the difference. And it's mentioned that 1% significant level, therefore alpha is 0.01. Now, it's mentioned that he has calculated the test statistics, right? That is 2.41. So now here, I need to draw the graph to decide. Now, to decide whether it's using the z-test, because here is mentioned z-test because of large sample here, right? So I will refer to the normal table to create the region. So when it is greater than, right, in the H1, that means it is upper tail test. So the region for this is 0.01. I mean the area of the region. Then now, from the normal table, you read the region of the probabilities of 0.99. So this value is going to be obtained from the body of the table, the normal table, and at last, you will be getting 2.326. Okay, so you have to write down rejection criteria. So reject H not if the Z is greater than 2.326, because the shaded region means the rejection region. Okay, so now given the Z value, he has calculated the value. The Z is basically 2.41. So 2.41. Alright, so now you have to mark this point 2.41 on the graph. So obviously 2.41 is inside the region. Okay, therefore our conclusion is reject H0 due to this rejection criteria. So you just write, since Z is greater than 2.326, therefore we reject H0. So when we reject H0, this is a decision. When we reject H0 means that we are supporting this. Okay, so when you supported this H1, that means you are supporting the suspicious of the architect, right? So that means now here I will just write, there is sufficient evidence at alpha equals to 0.01 to conclude that the buildings in the certain city are higher. In average. Okay, so that is the conclusion of this hypothesis testing. Question number 4. On average, 1 in 400 microchips made at a certain factory are 40. Now, the number of 40 microchips in a random sample of 1000 is denoted by X. Now, A, state the distribution of X giving the values of any parameters. So now, the microchips will be discrete random variable, and there are 1000 here. So then the probability of 40 is 1 in 400. That means 1 over 400. So which means now here n equals to 1000. The p is 1 over 400. So obviously this is binomial distribution. So x is binomial distributed with n 1000, and then the p is 1 over 400. Now B, state an approximating distribution for x giving the values of any parameters. Now, normally when the binomial distribution with large n, we will approximate it into probably normal distribution or Poisson distribution. So it depends on the calculation here. So now we will just do the calculation. NP equals to 1000 times 1 over 400. And then you will find that this is 2.5. Okay, and then probably I will just write, I start with n first. So the n is 1000, which is greater than 50. Then the NP is 1000 times 1 over 400. That is 2.5. And this 2.5 is less than 5. So whenever less than 5, we will approximate it to Poisson. Okay, so the approximating distribution so the Poisson is with the mean of NP. So this is your approximating distribution of X, which is Poisson distributed with mean 2.5. Okay, now see, use this approximating distribution to find each of the following. So now I will rewrite. My X is Poisson distributed with mean 2.5, and now Px equals to 4. So the formula, when the X is Poisson distributed with mean mu, so the Px equals to X, it will be E minus mu times mu power X over X factorial. Okay, so now your X is 4. So Px equals to 4, that is E minus 2.5 times 2.5 degree 4 over 4 factorial. That means you will be getting the value of 0.134. That is the value correct to 3 significant figures. Now part 2, X between 2 and 4 inclusive. So X between 2 and 4, that means this is same as Px equals to 2 plus Px equals to 3 plus Px equals to 4. So now, when you look at the formula, okay, actually, this E minus mu is constant. It means it's fixed. The only variable, the one changing, is the mu x over x factorial. So since the E minus mu is constant, is fixed for all calculations, therefore I will just factorize this exponential first, okay, for my part 2. So that means here I will factorize E minus 2.5. Then now, 2x equals to 2 means that 2.5 squared over 2 factorial. That is the mu degree x plus or over x factorial. Then this is 2.5 cubed over 3 factorial plus 2.5 degree 4 over 4 factorial. Okay, then from here, you will be getting 0.604. So that is the solution for part 2. Now D, use a suitable approximating distribution to find the probability that in a random sample of 700 microchips, there will be at least 140 microchips, right? So now your n becomes 700. The p remains as 1 over 400. So again now, your NP is 700 times 1 over 400. That is going to be 7 over 4. Or you can say that this is 1.75 and it's still less than 5. So when still less than 5 means that now it will be Poisson distributed. It's just that now the mean has been changed to 1.75. And now at least 1. Okay, at least 1 means Px greater equals to 1. For your information, just now, when the x is Poisson distributed with mean mu, probability of x equals to x is basically E minus mu power x over x factorial. And then the x values will be from 0, then 1, 2, 3 until infinity. So since now is at least 1 means all this. So we do not know when to stop. Therefore, I will use total probabilities, which is 1 minus Px equals to 0. Okay, so that is 1 minus Px equals to 0. So when Px equals to 0, substitute into this formula, it will be E negative 1.75. Then 1.75 power 0 is 1. Then over 0 infinity 0 factorial also 1. Therefore, the answer is just, it should have 1 minus So this is 1 minus. So this is your calculation or the steps, and you can calculate this value into 0.826. So that's the solution of this question. For question number 5, the volumes in liters of juice in large and small bottles have distributions. Okay, two different types of distribution. Now, large is L, so it's N, 5.10, then 0.0102. This is the variance. And then the S small bottle is 2.51, the mean, and variance is 0.0036. Now A, find the probability that the total volume in 3 randomly chosen large bottles and 4 randomly chosen 4 bottles is less than 25.5. So now here I need to find T is 3 large plus 4 small. Okay, so now I need to calculate the mean and variance. So the mean is ET, expected T. So now we have a formula, EAX plus BY. This is basically AEX plus BEY. Okay, therefore here I will get 3EL. So the EL plus 4ES. So the E is actually the mean. EL is the expected value, which is the mean. That is 5.10 plus 4 of expected S, so 2.51. And then you will be getting the answer of 25.34. Okay, there's a mean. And now the variance. Okay, now for the variance, you have to be careful because the question says this is 3 large bottles, right? And 4 small bottles. So the 3 and 4 here means that it is summation, right? Because large bottle 1 plus 2 plus 3. So when it is plus, we do not square. Now we have this formula AX plus BY. When these two are summation, okay, that will be A variance X plus B variance Y. But if let's say it is multiplication, so BAX plus BY, this will be the multiple. Okay, this is multiplication. Then we will write this as A square variance X plus B square variance Y. But now these 3 large bottles means it's a summation. That means we are going to use this formula. Okay, therefore you will get 3 variance L plus 4 variance S. Right, so that will be 3 times 0.0102 plus 4 times 0.0036. Then at last, you will be getting 0.045. That's the variance of the total. And now, from here, I will say my T is basically normally distributed. The mean is 25.34 and the variance is 0.045. Now, you need to calculate probability that the total is less than 25.5. So P, T less than 25.5. Okay, so since a T is normally distributed, as mentioned here, therefore we need to standardize. Now, when you standardize, X is normally distributed, mean mu, variance sigma squared. The standardized normal random variable, it will be X minus mu over sigma. Okay, therefore now I change my T into Z, then less than 25.5 minus the new mean 25.34 over this 0.045 is actually the sigma squared, right? I need to take sigma, means that I have to consider square root of the value. That is the standard deviation. And then now here I will be getting PZ less than 0.754. So when PZ less than 0.54, you can just read from the table, the normal table, that is going to be 0.7746. And now you round up the value into 3 significant figures, then you will be getting 0.775. So that's the solution of this question. Okay, B, find the probability that the volume of juice in a randomly chosen large bottle is at least twice the volume of the juice in a chosen small bottle, right? So now large bottle at least twice of the small bottle. So actually, if you want to write at least, it should be greater equals to, but then we know that it is normally distributed. You can just say L is greater than 2s, no problem. Okay, then I will move the 2s to the other side. Therefore, L minus 2s is greater than 0. So now again, I need to calculate the expected value. So this is going to be EL minus 2 expected x. Alright, then this is going to be, now for information, the formula over here, if let's say I add on the minus, this will be minus. If here minus, right, this is minus, this is plus. Okay, this is always plus for the variance. This is also here minus, this is always plus. Right, so then from here, I will get EL, which is the mean of the L, that is going to be 5.10 minus 2 of ES 2.51. That is going to be 0.08. Now for the variance of L minus 2S, alright, so probably I just do it here. Variance of L minus 2S. So be careful with the 2 here. This is twice. Twice means multiplication. So therefore, this is variance L plus 2 squared variance S. Okay, so then from here, variance L, because of twice is double, which is the multiplication. So variance L 0.0102 and variance S 0.0034. So just replace here. 0.0102 plus 4 times 0.0036, right? Then you will be getting the answer of 0.0246. And now you need to calculate the probability is that satisfies this. That means you need to calculate the probability that L minus 2s is greater than 0. So which means now L minus 2s, it will be normally distributed with the mean of 0.08, and then the variance is 0.0246. And now you need to count P L minus 2s is greater than 0. So therefore, again I standardize it. This becomes Z greater than 0 minus 0.08 over square root of 0.0246. This is your calculation. And then now here you are getting Z greater than a negative value. That will be negative 0.510. Now with this, we need to sketch a graph because of the negative value. Here is negative 0.510 greater than. Alright, then to get this probability, I need to reflect because your Z value is negative. So once I reflect it in the line of 0, the value becomes positive 0.510, and then the region will be the major region. Okay, so when I reflect, I will get this, which means the probability of Z more than negative 0.510 is basically same as probability of Z less than 0.510 when you refer to the graph. And right now, you can just read the answer from the table. That is going to be 0.6950. This is the value from the table. And now you can just round up to 3 significant figures. That is 0.695. So that is the solution of this question. Question 6. It is known that 8% of the adults in a certain town own a Candor car. After an advertising campaign, a car dealer wishes to investigate whether this proportion has increased. Okay, so now he chooses a random sample of 25 adults from the town and notes how many of them own a Canto car. Now A, he finds that 4 out of 25 adults own a Canto car. Now carry out a hypothesis test at the 5% significant level. So this is the hypothesis testing, and now here involves the number of adults. Therefore, okay, so here I will be using the proportion because this is proportion. Then later on we will use the binomial distribution to solve this problem. So now your H naught P is 8%, 0.08, but he suspect that it has increased. Okay, whether has increased, the proportion has increased, then it's the H1, P greater than 8%. And 5% significant level, alpha is 0.05. Okay, so now I will write reject H naught if, since we are solving this using the binomial distribution later on, because it is the number of adults, right? It is discrete. Now then look at the H1. Okay, when you look at the H1 over here, it's greater than. Therefore, for your critical criteria, rejection criteria, it should be probability of x greater equals to 4. Okay, it's less than the alpha value. Because of greater than, therefore, here is greater than. So it follows the inequality sign in your H1. Then now here, I know that this is binomial distributed. The n is 25, and then the p is 0.08. Now, the n is 25, p is 0.08. That means the q is 1 minus 0.08. That is going to be 0.92. Okay, so now we need to calculate this probability, px at least 4. So when at least 4, now your n is up to 25. That means supposedly you calculate from 4 until 25. But then now from 4 to 25, it involves a lot of calculations. What I need to do is I use the complementation rule. For your information, for binomial distribution, x is binomial distributed with np, the probability of x equals to x, that is ncx, px, qn minus x. And then the x value is from 0 until n. Okay, so greater equals to 4 means that I use 1 minus p from 0 until 3. That means this will be x less equals to 3. So here I will write 1 minus px equals to 0 plus px equals to 1 plus px equals to 2 plus px equals to 3. Okay, and now just use this formula. Now when px equals to 0 means that there is no success. So if no success, I will say all 25 are failures. Therefore, I will just write 0.92 to the power of 25. And then when px equals to 1 means that 25, 1 success. Out of 25, there is 1 success. The probability of success is 0.08, and then probability of failure will be 24. I mean, there will be 24 failures. Okay, same goes to the px equals to 2. Lastly, 3 successes. And then it will be 22 failures. So now when you calculate the total of the values inside the bracket, that will be 0.86491. So when you minus, that is going to be 0.135. Okay, so now refer to this statement. Compare with 0.05. That means this is greater than, right? 0.05. So based on this statement, okay, so we fail to reject H naught, right? So for the conclusion, or for the decision, I would say decision, since px greater equals to 4 is greater than 0.05, we do not reject H naught. So when do not reject H naught, the decision is done. The conclusion is we do not reject, means that we have to accept this. Or in other words, we don't have submission evidence to conclude the H1. Okay, because the dealer is investigating whether the proportion has increased. So there is not sufficient evidence to conclude that the proportion has increased because we do not reject H naught. Okay, then the proper conclusion is there is insufficient evidence at alpha equals to 0.05 to conclude that the proportion owning a candle car has increased. Okay, so that's the conclusion of the task. Okay, now B. Explain which of the errors, type 1 or type 2, might have been made in carrying out the test in part A. So now, part A, we do not reject H naught. Okay, so then, now, the just for information, probability of type 1 error is defined as we reject H naught, given H naught is true. Okay, and then the probability of type 2 error is defined as probability of do not reject H naught, given that H naught is false. Now, based on part A, we do not reject H naught. Okay, so from part A, the conclusion is the decision is do not reject H naught. Hence, do not reject H naught is type 2 error. Okay, have been made. Alright. Now later, the car dealer takes another random sample of 25 adults from town and carries out a similar hypothesis testing at 5% significance level. Now find the probability of a type 1 error. So P type 1 error equals to P reject H naught, given that H naught is true. Okay, so now look at the previous calculation, the part A. When it is greater equals to 4, okay, do not reject H naught. Alright? So then now, we need to get reject H naught. Greater equals to 4. Okay, so I have to calculate what is the probability of less than, because we need to reject H naught now. So when we reject H naught, means that the probability here must be less than 0.05. So now I know that greater equals to 4, it is greater than 0.05. So now I have to check what if it is greater equals to 5. Okay, do we still get greater than 0.05, then it is still do not reject H0. So now I will start with Px greater or equals to 5, where the x is binomial distributed, the n is still 25, and then the probability is 0.08 because H0 is true. So when H0 is true, your P, the proportion is 0.08. Okay, so now we have to do calculation. So when greater or equals to 5 is basically 1 minus P up to 4. Okay, so when P up to 4, that is 1 minus, because in the previous calculation, we have done up to 3. Look at here, up to 3, and I give more decimal places. So up to 4 means that I just need to add one more. This is up to 3, and then I plus when exactly 4. That's why you are encouraged to give more decimal places for the calculation. So when less equals to 3, the probability is 0. Here 0.86491. So I will copy this value and put it in the next calculation. So when Px goes to 4 means that it will be 25C4. So again, the P is 0.08, 4 successes, and then the failure will be 21. So here is going to be 1 minus, the total for these two values is going to be 0.95486. Okay, then when I minus this from 1, that is going to be 0.0451. So 0.0451 is less than 0.05. So when less than 0.05, based on the previous criteria, we are going to reject H0. Okay, which means now here Px greater equals to 5, I will say reject H0 when Px at least 5. Okay, because of less than 0.05. So now the probability of rejecting H0 based on here is also the probability of type 1 error. Therefore, probability of type 1 error is basically Px at least 5. That is going to be 0.0451. Okay, so that is how we calculate the probability of making type 1 error. Okay, so I have completed the whole paper and also comes to the end of the video. Thanks for watching. Please subscribe to the channel and share this channel with your friends if you enjoy watching my video. And stay tuned for more upcoming videos. Thank you everyone. Bye.